Hello and welcome to another Ginger Mathematician video where today we're going to go through all things upper and lower bounds. This is for the 058 course on iGCSE Maths. Right, let's get started. And they always use great names here. So Violet and Wilfred, they are recording their times to run 200 meters, correct to the nearest second. And whenever I'm doing an upper or lower bound question, one of the key things to do here is to actually identify what they're rounding to. So that's important. Now, Violet and Wilfred, one took 36 seconds and the other took 39 seconds. And we're looking for the upper bound here of the difference between the two times. So the way I'd break this question down is let's just identify the upper and lower bound for each person. So if we take Violet, for example, we have 36 right in the middle, and we're doing it correct to the nearest second. So what I'll be thinking about here is essentially 0.5 seconds, because that's going to give me the information to either round up to 36 or round down to 36. So my upper bound here is going to be 36.5, because everything less than that is going to round down to 36 to the nearest second. Likewise, the other side, if I have 35.5, then everything that and above is going to round upwards to 36. Now you're probably thinking 36.5, well that actually rounds up to 37, but I'm using this as a boundary. Again, writing 36.499999999 again is strictly correct, but 36.5 is that boundary, i.e. anything less than that will then round to 36. Likewise, we can do the same with Wilfred as well. So we've got 39 in the middle. Again, we're going to be considering 39.5. Everything less than that rounds down. And then 38.5. Everything above that and itself also rounds up to 39. And we want to get the upper bound of the difference between them. So we want to try and create the biggest difference we can from the information that we have. Now, one way we can do this is take the upper bound of Wilfred and the lower bound of Violet and take them away from each other. So we can do 39.5 minus 35.5. That's going to give us the biggest gap between the two times. And we can just work this out very straightforwardly. This is just going to be equal to 4. So our answer here will be equal to 4 seconds. If the question asks me for the lower bound of the difference between the two times, then we do kind of the opposite process. You're going to see this a lot in this video. So we take the 38.5, 36.5, so the lower bound of the difference would be 2 seconds. So it's not just important to understand how to do this particular question, but the variations of this question and how you would approach it. Right, so you can see the answer there. And notice we've got the NFWW, which we don't see that often. So this has to be not from working. So basically you need to have the working that supports this particular answer. You can't just write down answer, boom. You need to show how you've got to that. Right, on to our next question, which is a little bit different than questions you're going to see in this particular video. So pasta is sold in packets with width 11.5 centimeters, correct to the nearest 0.5 centimeters. Again, underlying that key knowledge is going to help us a bit later on. A shop places these packets in a single line on a shelf of length 2 meters, correct to the nearest 0.1 meter. And we want to find the maximum number of these packets that can actually fit on the shelf. Now, the first thing I'm going to notice in this question, which is different to what we've seen before, notice we're working here in meters, whereas this question we're working here in centimeters. So one of the techniques you're going to build in this particular video is making sure you're working with the same units, because then you can compare directly. So I'm going to take the bottom bit here. Again, you need to remember your basic conversions. So 2 meters is equal to 200 centimeters. That's important to realize. And 0.1 meters Well, that's just equal to 10 centimeters. So what the bottom is actually asking us here is we're actually at a shelf of 200 centimeters, correct to the nearest 10 centimeters. Now we've got everything in the same unit, we can start looking at this problem. Now we want the maximum number of packets on this shelf. So we want the maximum shelf possible. So the upper bound of shelf. So if we take this 200, so I'm going to put this in the middle, I always consider half of what we're correcting to, so that's 5 centimeters, and then we can form our upper and lower bound. So our upper bound will be 205, and the lower bound will be 195. Again, if it's equal to 195, to the nearest 10 centimeters, we'd round up to 200. If it was 194, we'd round down to 190. So we want the upper bound here. So this is our upper bound, this is lower bound. So we want to use this 205. Now we're actually going to take the packets of the pasta themselves. So this 11.5, so we're going to pop this in the middle. And then we need to find the upper and lower bound for that as well. So if it's correct to the nearest 0.5 centimeters, we are considering half of that, which is 0.25 centimeters. So if I add 0.25 in this direction, I get 11.75. And if I take away 0.25, this gives me the lower bound of 11.25. And we want to fit on as many packets as possible. So we've got the biggest shelf possible, but then we need to have the smallest packets possible to fit onto that shelf. So I want to consider the 11.25. So each one then is 11.25 centimeters. The shelf is 205 centimeters. How do I work out how many packets go on there? Well, it's just going to be 205 divided by 11.25. How many 11.25s fit into 205? So we're going to go over to the calculator and let's see what it tells us. So we've got 205 and we're going to divide by 11.25 and then we're going to get the answer of 18.22222. Now we have to be very careful with these kinds of questions. You'll see this later in the video, exactly what the question is asking for. And we want the maximum number of packets. Now these come in whole number packets. We don't get a quarter of a packet or an eighth of a packet. So we're looking for the whole number that fits. Well, we get 18 full packets that actually fit on our shelf. So our final answer here is going to be equal to 18. Because the 0.222 packets, again, 19 won't fit on the shelf, but 18 certainly will. So you can check your answer. Again, the NFWW is there. Be aware on upper and lower bound questions. That appears on a lot of different mark schemes. Right, on to our next question, a bit more of a straightforward question here. So the lengths of the sides of a triangle are 11.4, 14.8, 15.7. Again, this time correct to one decimal place. So that's important to realize. So that means we're going to be considering then 0.1 because we want that one decimal place here. And we want the upper bound of the perimeter of the triangle. So remember, to work out the perimeter of a triangle, we're just going to add the sides together. And because we want the upper bound, we want the upper bound of 11.4, upper bound of 14.8, and then upper bound of 15.7. So let's just take one of these as an example, and we're going to do the same process for each. So if we take the 11.4, we put that in the middle. We want half of this, which is 0.05, and that will then give us our upper bound, which is 11.45, and then 11.35. And because we want the biggest perimeter possible, we always want to take the upper bound of each side, which in this case will be 11.45. This works for the other sides of the triangle. So 14.8, the upper bound will be 14.85, upper bound of 15.7, 15.75. So we pop that into our calculator. So I'll just do that here. So 11.45 plus 14.85 plus 15.75. That then gives us 42.05. And this brings me to a very important point with these kinds of questions. Do not round. So when you get your final answer of 42.05, which is correct, The one thing that you do need to consider here is it's tempting to round this to 42.1 because your teacher has told you round to 3 significant figures, 1 decimal place. In an upper and lower bound question, please don't do that. Please don't do that. You need to write the exact precise number unless the context of the question, like in the previous one, tells you otherwise. So please write this exactly as is. As you'll see in the mark scheme here, it wants 42.05. That is the final answer. If you do not put that there, you will lose a mark for this question. Okay, on we go to a nice little twist on upper and lower bounds here. So this is question 12. So f is a common factor of 14 and 28, m is a common multiple of 10 and 25, and p is a prime. And we want to work out the largest possible value of this fraction here, f divided by mp. Now this is something we're going to see a lot in other contexts of questions. Whenever you get a fraction, so if we want an upper bound of this fraction, and this works for speed, distance, time, and a lot of other questions here, the way we want to do this is we want the biggest number possible on the top of the fraction, so the upper bound of f, and we want the smallest bound, the lower bound of m, and the lower bound of p. So whenever you get a fraction question like this, to get the upper bound of this fraction, you want the biggest thing on top and you want the smallest at the bottom. Because if you divide by a small number, it's going to actually make the fraction itself actually bigger. So let's go through this process. So we want the upper bound of f. So we want the biggest factor that goes into 14 and 28 as well. Well, remember, 14 is a factor of 14 and 14 goes into 28. So our upper bound of f, the biggest number we can find, is 14. Now we need the lower bound of m. So we want the lowest multiple of 10 and 25, which is a common multiple of both. So if we want to do that, then if we've got the 10 times table, so we get 10, 20, 30, 40, 50, 60, and we want the lowest number that they share. So 25, 50. So 50 is the lowest number that they share. So that's going to be 50. And then we want the lowest bound of p, so the smallest prime possible. Now that's not 1, but that's actually equal to 2. Remember, 2 is the smallest prime number. Then we pop this into our fraction, so the upper bound of f over mp, this will be equal to 14 divided by 50 times 2. Now you can do this on your calculator, but actually we can do this without it. So 50 times 2 is 100, and if we do 14 divided by 100, that's going to equal 0.14. Again, dividing by 100, you're going to shift all the place values twice. So this gives us the precise answer, again, no rounding or anything like this here, of 0.14. Again, you can see the working here. Again, or equivalent, so OE. So if you wrote your answer as 14 over 100, that would give you the marks, or even 7 over 50. So again, if you're writing it as a fraction or a decimal or a percentage, you're still going to get all 4 marks for this question. Okay, and let's move on to the next question. So Neha has a piece of ribbon of length 23 centimeters, correct to the nearest centimeter. So correct to the nearest 1 centimeter. We'll come back to that. From this ribbon, this is where you have to read the question carefully. She cuts off a piece with length 87 millimeters, correct to the nearest millimeter. And as soon as I see this, I'm getting alarm bells in my mind because I've got a millimeters calculation and I've got a centimeters calculation. So I'm always keeping that in mind as I go through. And what we need to do is work out both the lower bound and the upper bound for the length of the remaining ribbon. So that's important. So what's left over once I've taken off that piece. And we're told in the question, work in centimeters. So if we're working in centimeters, then we need to change 1 millimeter into centimeters. That's equal to 0.1 centimeters. And then 87 millimeters, well, that's equal to 8.7 centimeters. So use the question. Again, we've got the units here that we need at the end, and that will tell you which unit to convert into before then we start the question. So let's work out some upper and lower bounds. So let's start with the actual ribbon itself. So let's do upper and lower bound here. So this is 23. Half of 1 centimetre is 0.5. So our upper bound will be 23.5. Lower bound will be 22.5. Again, we're adding and subtracting 0.5. And then we've got the piece of ribbon cut off. Now half of 0.1, that's 0.05. So we've got 8.7 in the middle. Again, same units. That's important. And then we're adding 0.05, so 8.75, and then 8.65. This is where we have to be careful with the question. So we want the lower bound and upper bound of the remaining ribbon. So let's look at upper bound of remaining first of all. So we want that to be as big as possible. Now in order for that to happen, we want the biggest ribbon possible, but we want the smallest taken away. So we do 23.5, so the biggest ribbon we can have, but then we want the smallest amount taken off, which is 8.65. And if we want to work out the lower bound, it's the other way round. So we want the smallest piece of ribbon possible, so that's 22.5, and we want to take off the largest amount possible, which is 8.75. So if we work those out, so 23.5 minus 8.65, again you can do on your calculator, this is 14.85, and if you want the lower bound, if we take these away, we can get 13.75. So lower bound is 13.75, and our upper bound is 14.85. Again, reading through the question, understanding exactly what you're trying to achieve will then help you choose the correct upper and lower bound from what we did in this part of the question. So you can check your answers here. So 13.75, 14.85. Please don't make the mistake of putting the wrong bound in the wrong place. So always do a double check. Lower bound should be the smallest number. Upper bound should be the biggest number too. Right, on to our next question. So this comes from a paper 4, which is following on from a more extended question. So at the football match, there are 29,800 people, correct to the nearest 100. So I'm going to underline that. At the end of the football match, the people leave at a rate of 400 people per minute, correct to the nearest 50 people. Okay, so we've got the information there, and we want the lower bound for the number of minutes it takes for all people to leave. So first of all, we need the number of people. And again, we're just going to write down upper and lower bound and then work out what we need from that. So we have 29,800. Half of 100 is 50. So we've got 29,850 as the upper bound, and then 29,750 as the lower bound. And then we've got the rate here, which is 400 people a minute, so we put that in the middle. Half of 50 is 25, so we've got the upper bound of 425, and then we've got the lower bound of 375. Okay, and let's think about what we actually want to achieve here. So we want the lower bound, so the quickest amount of time, put it that way, for the people to leave. Now, for the quickest way of people to leave, we need the least amount of people, which is this one here, and we want to get them out as fast as possible. So we need to use the upper bound to get rid of these football fans. And if we want to work out the number of minutes it takes, then we're going to take the number of people, 29,750, the smallest possible, and divided by the largest rate so we can remove them. So we need to do the calculation here of 29,750 divided by 425. Let's do it on the calculator. So we've got 29,750 divided by 425, and we get exactly 70. Okay, so a precise answer. So our answer here will be it takes 70 minutes for them to leave. Now, if you get confused in a question like this and you're not sure about the answer here, one thing you can do is try it the other way around. So we could do 29,850 divided by 375. Does that give you a bigger number or a smaller number? If it gives you a bigger number, then it can't be, by definition, then the lower bound. So if you ever get really stuck and you're not sure which one to divide by what, just try out the lower and upper, lower and upper, upper and lower, and then lower and lower, upper and lower, upper and upper, and then you can always find out which is the lowest. Takes you a bit more time, and this is why this video is here to help you, but you could use that method too. Now on to a follow-up question here. So we've got a cricket match, 27,500 people, correct to the nearest 100, and we want the upper bound for the difference between the number of people at football and at cricket. So we're going to copy over the information from before. So we've got 29,750, 29,800, 29,850. So this is going to be football. And now we want cricket, so we do it in the same way. Half of 100 is 50. So we've got 27,500 in the middle, 27,550 is the upper bound, 27,450 as our lower bound, and we want the biggest difference between them. So the way that we would achieve that is we take the upper bound of football and then the smallest bound of cricket. Now notice they're both rounded to the nearest 100, so again you could do it the other way round as well. So you've got 29,850 minus 27,450. Again, this could be something you could do in your head if you wanted to, and this is going to give us 2,400. We do that subtraction, so we get our final answer of 2,400. So you can check your answers here. So notice we've got the 70 here and the 2,400 again, the NFWW, so make sure you're showing your working as you go through this kind of question. Okay, on to our next question here. So this is question again from a paper 4, and notice we've got 7a here. Now I'm not going to go through this particular question in this video, but I've done a video exactly on these questions, so you check that out above where I go through similarity in about 40 or 50 minutes. But we're going to focus on question B here, which is a picture in the smaller frame, has length 15 centimeters and 10.5 centimeters, correct to the nearest 5 millimeters. Again, warning bells, centimeters, millimeters. We're going to have to do something about that. Calculate the upper bound for the area of the picture. So the first thing I'm going to do here is change those units whilst I remember. So remember 5 millimeters is the same as 0.5 centimeters. And if you want the area of a picture, so a rectangular picture here, well, it's just going to be the length times the width. So A is equal to L times W. So we want the upper bound of both here, and then we can multiply together. So if we work out the upper bound, and you're probably getting used to this at the moment, of the length, well, we can work this out quickly. So 0.5 halved, that's going to be 0.25. So we just add that on to both. So we're going to get 15 plus 0.25, that's 15.25. And then the upper bound of the width, be careful with your decimals here. So 10.5 plus 0.25, that's equal to 10.75. So all we're going to do is multiply those numbers together. Let's use that calculator we've got. So we've got 15.25 multiplied by 10.75. And that gives us 163.9375. 163.935. So our answer will be 163.94. Ah, you fell for the trick, guys. If you fell for the trick, then do put it in the comments. If you didn't, also put it in the comments as well. Remember, with these kind of questions, so let me just scribble this out. I'll just scribble it out instead. Whenever you're doing an upper lower bound question, again, you try and leave it in the exact form you're given. So 3, 7, 5, like so. Be very, very careful. Got an upper bound question, just write in the entire decimals you're getting from your calculator. So you can check your answer here. So notice we need that exact value in order to get to that answer there. Right, on to our next question here. So a bus travels 440 kilometers, correct to the nearest 10 kilometers. And the time taken to complete that journey is 6 hours, correct to the nearest half hour. So a half hour, which we could also write as 0.5 hours, and you'll see why that's useful. And we want the lower bound of the speed of the bus. Now, as soon as I see a speed question, generally speaking, again, this could be on any iGCSE question, remember that speed is equal to distance divided by time. So let's write down the upper and lower bounds for both distance and time, and let's see how that fits in to get our lower bound. So we've got 440 kilometers, correct to the nearest 10, divide that by 2, we get 5 kilometers. So we've got 440 in the middle, and then we have 445, and then 435 as our lower and upper bounds. Likewise with the time here, again, we want half of 0.5, that's 0.25. So if this is our number in the middle, 6 hours, then we've got 6.25 as the upper bound, and then 5.75 as the lower bound. And we want the lower bound of the speed. So we've already seen this kind of fraction question about upper and lower bounds. So have a think. I'll give you about 10 seconds. How do you work out the lower bound of the speed, given we've got a fraction in this case, which we've already seen in a previous question? Right, so if we've got a lower bound and speed, we want the smallest distance, so the 435 divided by the maximum time taken. So we're going to take 435 here and 6.25. So we're going to 435 divided by 6.25. So if we want to work this out, we can just use our calculator. I'll do it here this time. So we've got 435 divided by 6.25. That gives us 69.6. Again, don't be tempted to round to the nearest whole number. Leave it as 69.6. And if you're not happy with that and go, okay, is that really the lower bound of the speed? Again, you can do 445 divided by 5.75. Will you get a different answer? Which is the lowest answer that you will get? So you can check your working here again. You can see to get all the method marks, you just need to write that fraction with the appropriate bounds so that you can get to 69.6. If you want to revise your algebra skills and just make sure you're up to scratch with working with algebra, we've done a lot of number work here, but if you want to work on your algebra, then check out the video in front of you. Go spend about 50 minutes here just going through all the standard skills you need, your factorizing, your expanding, and even some of the splitting the term with double brackets, which can be quite tricky for iGCSE pupils.